Thank you to all of our attendees joining us today. Like Brian said, my name is Remy DeCausemaker. My preferred pronouns are he, him. You can follow me at Remy_D, and you can email me at remy@decosmaker.org. These slides, as humble as they are available on my GitHub. So github.com/decause/dex/ato-decause-2020. And today's talk is titled Cultures of Contribution, How Contributions Flow, and What It Means to be a Contributor. And because this is all things open, I wanted to send a special thank you and a shout out to Todd and Danny and all the other tireless organizers and volunteers who've been working on this becoming the largest East Coast open source conference in the United States. I've had the privilege of being invited and accepted to speak at ATO, oh geez, for at least 7 or 8 years now. So I really wanted to take a moment to recognize that this is something like any other open source project that grows and becomes what it is because of the participation of people like you, the folks on the stream, the folks like Brian, and the folks who make this what it is. So I just wanted to recognize that effort and say, super shout out, super thank you. Thank you for having me again. Really appreciate the opportunity. So, cultures of contribution. Let's talk about it. There are two elements to this talk, at least to the title. The first one is contribution flows, and the second one is what does it mean to be a contributor? So before we can talk about what it means to contribute, let's talk about what a contribution is. So in this little folk realm of describing open source in a descriptive way, using clever analogies and metaphors, I'll be using a bunch. Stuff that I don't make up myself, I try to provide references for, but some of this stuff is made up and based on things that have been published by other folks, other places you can read about it. Um, we all stand on the shoulders of giants, and open source isn't just one community, it's a community of communities. So anybody who tells you this is the one and only way to describe contributions or contributors is probably not being honest with themselves or with you about sort of the plethora of viewpoints and approaches to doing open source contribution and work and working together. So this is sort of caveat Remy's version. So in Remy's version, contribution has a few elements. The first thing is that it's voluntary. The second thing is that it was contributed for a purpose. The third thing is that it solves an existing actual problem. And the fourth thing is sort of a bonus. It's just ideally it doesn't waste time or resources. So with voluntary, that means self-selection. And in the realm of open source, there is this idea that the best motivators that you can have to do difficult work, especially when you don't exactly know what the nature of that work is going to be, is self selection. You are going to be most excited about diving into projects that you care about. You're going to be most motivated to figure out the hard problems if they are problems that you're genuinely interested in. So, whether a contribution is coming from a person who has a full-time job who's paid to do this or a random person who's just doing this as a hobby on the side, they're still choosing, they're still volunteering to make this contribution. So that is a really key, important differentiator in the world of open source. And that idea of choice versus force. So I'm still choosing to make this contribution. I'm still using the tool that is available, or I'm still contributing to the tool that's available because there are alternatives. There are things that you could be using otherwise. And the fact that you are using this one, even if it's free, even if you're not forced to do it, that is that element of self selection once again. The second element is that it's for a purpose. A lot of times it starts with scratching your own itch, as it's called in open source. The idea that you solve your own problem for yourself. And then if it solves somebody else's problem too, cool, great. And if we work on it together, then maybe even we can prevent future itches from coming up, right? Uh, whether you're doing that as a work for hire, somebody has hired you to work full time on an open source project as a gainfully employed person, or whether you're on your path to getting involved in open source and primarily you're contributing with a passion for learning or exploring or being a user. Either way, contributions come with a purpose. I think that there's a lot of folks who sort of assume that like if you build it they will come and contributions just materialize out of thin air and that people contribute for no reason in particular at all. There's just all these people waiting on the internet to help you do your project. And though that is maybe the case in some fields or domains, it is often not the prevailing atmosphere. So I think it's important to point out that contributions oftentimes come with a specific purpose in mind. And the implicit purpose of the contribution, whether you're solving a particular problem or not, is that you don't want to waste your time or resources. Communities, like many other systems, have finite energy. And if a contribution doesn't persist or it cannot land, then that energy will find another path. This idea sort of tags along with the law of conservation of effort, is what we're going to call it today, as opposed to energy. So, wait a minute. Isn't law of conservation of energy like a physics thing? Yes, it is. And energy can be thought of as just, or effort can be thought of as energy over time. And describing effort takes both an artistic, creative mind to describe these abstract and metaphorical analogies, but there's also some science that prevails and some governing principles that guide the types of effort and where it goes and how quickly and when and how. So, we're going to talk about a couple today. There are definitely more than a couple, but there are two that I want to highlight particularly in this talk. The first is the principle of least action. Um, this is colloquially understood in hacker and contributor communities and open source in the expression lazy like a fox. That is, people don't want to do more work than they have to, and they don't want to spend more time than they have to. So, the principle of least action in open source can sort of be described as the thing that will take the least amount of effort in the least amount of time that gives me the best quality and exposes me to the least amount of risk. This idea of the principle of least action was sort of how I got started on this whole talk. It turns out that there are a lot of really brilliant mathematicians, scientists, in a variety of fields who have come to this idea of the path of least resistance or the principle of least effort. Um, these concepts apply beyond just the little talk I'm giving today. Principle of least action can be used to describe why heat goes from hot to cold in thermodynamics. It can be used to describe why electrons will take a particular path on a circuit board in electrical engineering. It can be used to describe why animals choose the lowest point on a map or the least difficult path to traverse through a forest. Whether it's physics or biology, astronomy, astrophysics, the principle of least action continues to show up across a number of disciplines. So I figured I would abuse my right here to present about it and apply it to open source because I believe that humans also know this innately along with animals, and it's the physics of effort that really drives how people do this work. So, the principle of least action, lazy like a fox. This is a key piece that we'll talk more about in a minute. So, as I said, it's an art and a science. Let's start with some really bad art. This is a picture. Let me set the stage for you. Imagine you're a villager on one side of a river. Imagine there's a village on the other side of the river where you can trade. Each day, you get one block to use. Villagers are lazy, I mean wise, and prefer to take the shortest path, aka the principle of least action. So, if you can get villagers on each side to agree to put their blocks next to each other, you can build stepping stones and you can get across. But what if you don't know where they're going to put their blocks? If you put yours where you want and they put theirs where they want, it turns out that you can't actually cross the river. So, ideally, you want to be in alignment. You want your blocks to be aligned with the blocks of the other people across because you both have only one block a day to use and you only have one day to spend. So, ideally, you want the conditions to line up and you want your work to build off each other so that you both can mutually benefit. It's a very simple little simulation we have here. The problem with rivers, though, is that they don't stand still. Rivers are constantly moving. And in the physical world, it's kind of difficult and we have limitations of physics. But in the world of software, what if we could actually change how the river flowed so that the boxes would stay where they were put, or that the natural forces would tend towards keeping things in order rather than them separating and coming out of alignment? Um, this is a fun little thought experiment, and we're going to continue building on this story as we go forward in the talk. So let's say that we're on that same river, and here's our representation. On one side, we've got the block provider, and on the other side, we have the block seller or buyer. And if you're on one side and you want to get across, you want to take the least amount of time to take your block and sell it. So, which way are you going to go? Are you going to go on path one or path two? Well, if you didn't know better and you were not sure, you might end up taking path two. But you might see and observe from the community around you that somebody else took path one. And because they took path one, it's really apparent that it takes a lot less time to walk your block from your side of the river across and then to the place where you can sell it and trade it for other things. So now, knowing that, you say, well, wait a minute. If we both don't know where our blocks are going to go, and we can go in either the first column or the second column, what are we going to choose? Though the path of least action, or the principle of least action, would tell us that, hey, actually, it takes a lot less time if we start with the path that's closest to the place upstream. So there's a good chance that even though these two villagers don't know where they're going to go and they don't necessarily speak the same language, they do know that it takes longer to walk farther. So it's an obvious decision that if both of you can put your blocks as close to the booth as possible, you should. That's the physics of it. Pretty simple. So, with that in mind and with that example, let's talk a little bit about what it means to be a contributor. And there are some other principles that we're going to talk about today. So, another phenomena that is sort of emergent in the world of not just open source, but lots of other places too, is called the Pareto Principle, uh, informally known as the 80/20 rule. It can be described as roughly 80% of consequences are derived from 20% of causes. In a software centric description of the world, this might manifest as 80% of the code only takes about 20% of your time to build, but the hardest 20% of the code takes the other 80% of the time. Another way of describing this 80/20 split could be that 80% of contributions come from 20% of contributors. There are many other examples of the Pareto principle in action, and it can be used to describe behavior in lots of places, not just software. But we're going to stick to the software and open source specific because we're at All Things Open today. But I would highly recommend checking out the Wikipedia article on the Pareto principle and finding out about the history and all the different places that it applies. So, in the world of open source, that 20% core, well, how do you find them? If that's the important part of being a contributor and you know that 80% of the work is going to be done by that core people, how do you find them? It's like the village on the other side of the river where you may not know where they're going to go and you may not even speak the same language, but we still want to connect. So there are a couple of things you can do to find them. Friction ambiguity, and uncertainty. These are three barriers to taking the path of least action. So, if you want to improve the likelihood that someone's going to take the path, you can start by reducing friction. When we think of friction, we can do another cute little stick figure analogy. Think of a contribution as a big old boulder, and you're a contributor. And the friction for getting that contribution upstream or added to a project is like how much effort it takes to move the boulder from one place to another. Let's say that in ideal circumstances, if there's no blockers and the path is certain and there's no ambiguity, then it's probably like a 2 out of 10 effort to get you there. And you can think of all the steps that you take along the way to get your contribution into the project like a path. And it might start off being easy, but maybe there's some barriers in the middle where you have to go uphill and the effort becomes harder. But once you get it up the hill, there might be infrastructure or processes in place that make it easier once the project gets through that barrier of entry. So you have reducing friction as a way to make it more likely that contributions will come to you. And if these contributions are the kinds of things that we want to build upon, it would be nice if they were generalized. If roughly all of the contributions were of the same size, if they covered roughly the same amount of complexity, and if they were contributed by a broad array of people so that any one person not being around in the project, aka the bus factor, uh, or the boss factor, or whatever you want to call it these days. Check out chaos.community for the latest jargon. Um, whatever the case may be, you want to ideally see your contributions be relatively uniform, relatively reproducible, and come in the same way. In reality, this isn't how projects are built. They usually look more like this, where we have the majority contributor, maybe a large contribution coming from a core team, and then the smaller contributions that sort of frame it and are around it. And these all sort of depend on each other. And when you get into a really big community, you might see a plethora of different kinds of project contributions coming in. There might be core contributors with the massive core. There might be some plugins on the side where people are adding contributions of their own size and complexity, covering different kinds of things that may not be part of the core. And then maybe a few missing links where people have a particular bug or a hole that they needed to solve for themselves, and why not? We can just contribute it back up. So you can see in this little diagram here, this represents sort of a heterogeneous mix of core contributors and community members and some drive-by patches, sort of all jumbled together into one relatively undifferentiated bridge, if you will, that you can use to cross the chasm. So if that is about friction, then let's talk about ambiguity and uncertainty. So, another helpful metaphor that I use for describing sort of how software works together in stacks, I imagine a stack of disks, and those disks each have a bit of a keyhole in them, and each one of them is their own project. And as long as all the dependencies are aligned, then the work you need to do, the path to least resistance to solve, to meet your purpose, can go through this stack. And when I'm thinking about how teams of people depend on each other, both inside of a company and outside of a company or across communities, I imagine sort of exploding out this graph. And each one of these disks might be rotating at a slightly different pace, or each one might have slightly more tolerance for how big the hole is, the keyhole through which you can find the path of least resistance. But this is the analogy that I imagine when I'm thinking about how to get people aligned. If you are hard depending on something else below you, and that version is there, then you can assume that the next version on top of it is going to work if somebody else across the river is using the same path as you. And as long as you keep your stuff in alignment with the other stuff that's happening, then the path of least resistance can remain. So by removing ambiguity and creating alignment, that's how I think about how this stuff goes through. So the other element that I want to talk about isn't that, work isn't usually undifferentiated. You can build a bridge across a river by just throwing different sizes of stones in there in a pile and hoping that they work. But like we said, there's only so many stones or blocks that we can have in a day. There's only so much time that can be done. And software isn't undifferentiated. It doesn't have a non dependency relationship. You can imagine it more kind of like a masonry arch, where each element depends on the element next to it, and there's an order to it. And each of the components relies on each other, and those contributions can be done in a particular order. And if they are accomplished, then it creates a system where there's mutually assured progress, where you're building on the progress of others. And it can be more advanced, it can be very granular, or it can be more general. Here is a really nice diagram that I stole from Wikipedia at the link below, and then artist's approximation of what a more rough system would look like. But the principle is the same. If you had to stand up this type of a bridge, you couldn't do it just by throwing the rocks into the water randomly. You'd have to actually stand each one up individually and support them until you could get to the middle to meet in a keystone type situation. And by having this type of alignment that's implicit in the structure, you can get people to understand exactly what the next step is, even without telling them that. By creating a structural expectation around your project and the code, you can actually align people's purposes just by what kind of blocks you're using, how big they are, how hard they are to move, how many you can send at a time. All these different constraints about the materiality of the contributions actually dictates the physics of things, which is exciting because in software, we can break the rules a little bit. So let's go back to our two sides of the river. Let's make the constraints a little bit higher. Let's say that it's not just a little river that you can wade across, but it's like a big old cliff and there's a chasm between you. It'd be nice if you could just say, yeah, we need a bridge. It's a block. It spans the entire way. And we both agree that it needs to look like this and it should be awesome. The problem is that things are rarely built that way, especially bridges. If there was something that was just long enough to cross the span, then you would just use it. But bridges have to be built out of components. So let's say that each side builds about half of it. And you know that if I go halfway and you go halfway, we should be get across, right? The problem is that without anything in the middle, a sort of central point to build towards, you won't know if those are going to meet up, or you won't know if you're going to put them on at the right time. There needs to be some kind of mutually understood rally point. Enter open standards, enter open source, enter dependencies. There are a lot of different ways that this pattern comes to be. But if you can expect that this one piece in the middle is going to be there and it's going to stay, and that it's shaped in a certain way, then you and each side can come up with the pieces that'll fit in between. And understanding the utility of the work that you're doing and how it serves your purpose, and relying on the other side's purpose to be maintained through the utility to do what they need to do, you can actually get where you want to go. So these are fun analogies and they're cute to talk about. But let's boil it down a little bit. A culture of contribution has a few things in it that help to enable people to be aligned, to reduce friction, reduce ambiguity, and reduce uncertainty. One is planning in the open. The more transparent you are about what you're going to do, the more clear it is where the other side should be putting their blocks, right? If you say, I'm going to put my block as close to the other side as possible tomorrow, and the other side knows it, they're pretty likely to put their block as close to yours as well to reduce the amount of time that both of you need to spend and the amount of energy and effort that goes into moving the blocks. Adhering to open standards is like putting that pylon in the center, where if both of you can rely on a common architecture or a common implementation path, then your pieces are more likely to fit and more likely to stay when you put them down. By using release engineering best practices, how you ship your blocks and how often they move, by being clear about those expectations, you actually make it easier for folks to come in and out of your project, whether that's continuous integration and testing, whether it's revision control, whether it's open communication channels, whether it's semantic versioning so that your releases are clear when they're shipped, whether or not they're backwards compatible or not. All these different best practices help to reduce ambiguity and align the different sides of the contribution river. By doing it so that both of you are using the same bridge, you are aligning and mutually assuring your progress. This makes it really fun to work together because the more blocks you build, the more utility you get from the structures that are made out of the blocks. And this aligns your purpose. The idea of becoming the path of least resistance is how you create a culture of contribution. You can try to convince people, you can try to trick people into doing things, but really the physics of this thing helps to determine whether or not which path is the obvious one. On the flip side, sort of in the bizarro world, we can talk about a culture of capture. And I don't want to talk too much smack about the culture of capture because really, on its face, a culture of capture and a culture of contribution are both doing their best to minimize friction, to minimize uncertainty, and to minimize ambiguity. These have slightly different ways of going about it. So, information asymmetry is a big part of a culture of capture. The idea that it's the sort of bizarro version of planning and communicating transparently. If people don't know where the work is going, then they might make decisions with imperfect information. And when they have imperfect information, there are margins, and margins can be exploited. So, information asymmetry is a big part of helping to reduce uncertainty. If you don't know there are options, then you're only going to pick the ones you know about. Vendor and proprietary lock in are another common tactic in a culture of capture, where if I have my standard, but it is a very special shaped standard, and your blocks only fit if you get them from the same place that I get them from, then that ensures that there's less uncertainty to the mix. There's less heterogeneity amongst the contributions. This can be a positive. And I can understand why control is one of the things that is used in keeping things the same. So, bottlenecks and gatekeeping are another tactic. By controlling who can contribute and how often, you can actually do a lot of directing of where the energy goes and how the effort is used. As we talked about before in a culture of contribution, you want your work to be utilized and you don't want it to be foregone or replaced or disappear. And that understanding of mutually assured progress, excuse me, that keeps people on the same path and in alignment. But another way to align people is by putting an expiration date on those contributions and saying, when they're all over with, you're going to be, you know, this isn't going to last forever. It's only going to last for a while, and we're going to have to come up with the next thing. When people don't assume that things will be there forever, then they contribute differently and they use their effort in different ways. So, manufactured obsolescence keeps people coming back to your place where they're getting the blocks, but it also, reduces ambiguity and creates an alignment of itself. And along with the analogy of the path of least resistance, you can also create a path of most resistance. If the alternatives have more friction and more ambiguity and more uncertainty, then it turns out that maybe the path of least resistance isn't the naturally least resistant one, or the one of the least resistance of all, but it's the one that's the least resistant that you know of. So you still might end up taking that path too. So, culture of contribution, culture of capture, both trying to do basically the same thing, just slightly different results or slightly different tactics for how they do it. So, the nice thing about this simulation that we had is that it's very neat and it has a certain physics that bounds it. The direction of the river probably won't change. The direction of gravity doesn't change. The location of the villages won't change. The location of the villages relative to each other or relative to the river. The population won't change that much. The rules of using roads won't change. All these different things are nice and neat and tidy. But in the world of software, the physics aren't just about scarcity. It's not just a zero sum game. It's a little bit different than the obviousness of where we can walk. Um, in this world, when we align things, like let's say that if you could get people to agree to put three of their blocks next to each other, it would create a road. And a road could put a wagon on it. And the wagon can carry way more blocks than you could carry by hand. So by aligning incentives and increasing the marginal utility of working together, you actually create a culture of contribution, mutually assured progress. But if the rules could change and they were different, let's say that there was a man in a hat, and that man in a hat had a cane. And with that cane, he could create portals and wormholes into different pieces and parts of the world you're in. And what if those portals could transport between different parts? All of a sudden, the path of least resistance isn't physically obvious. It's not just a matter of whether or not your block is closest to the vendor station. Now, with this new physics, you can actually create special links between different parts of the world. So, the physics of doing software and linking and are not just the same as throwing blocks into a river. If the physics were different, if the river could flow in any direction, if gravity could change, what if instead of it being one side of a river, the topology was different? What if it was a series of islands in an archipelago? And it wasn't just about getting across one side of the river to the other, but across a system of islands. And if each of them could have their own replacements and dependencies, and there could be shortcuts, all of this would drastically change the path of least resistance and the path of least action. So, in imperfect systems, when there are shortcuts, we actually see the potential for ambiguity and uncertainty to creep back in, as opposed to ones that have the physical bounding. So, rather than continue going on in this thought experiment, I wanted to leave it there. I would really like to continue building out these little simulations and physics drawings and helping to speak more to what it means to be a contributor and why people work together. I think that the physics of path of least resistance make a lot of sense, but they aren't the only thing. And it's where there's actually more uncertainty, ambiguity, where I'm interested in hearing about sort of how people navigate those systems and coming up with new analogies to describe that too. So I think at this point, it's a good idea for me to cut it off and to open it up for questions because this has been a fun little romp through the abstract, and I want to hear what folks have to say.
Outstanding, Remy. That was great. I love the examples and analogies that you shared. I've never thought about it that way, but it does really make sense. I mean, with open source, that's really great. I don't I don't see any questions, but I was thinking of one though. What do you say about hackers and potential bad agents out there with open source? Do you see it as, the open source community being, when someone knows I guess the rule book, or they've got the blueprint, does it make it easier, or do you think that
Hmm.
there's enough good agents out there that, to thwart those threats or those types of, what are your
Yeah,
thoughts?
yeah, this is a great question. The the cute principle or the tie it up nicely analogy is security through obscurity, right? So it's sort of the throw a blanket on it version of security, where you say, if I don't look at it and I don't tell anyone there's a problem, then maybe nobody will find out that it's there. And that's a nice thought, but it didn't work in the Death Star, and it does not work at Helm's Deep, and it doesn't work in open source either. Someone will find that path. With transparency of the code, it's clear where the river is and where the shortest paths are across it. The idea that you can pretend that they're not there, that's one way of going about it. Or you can be thorough and you can say, well, we know that here's the path of least resistance, the drain that goes under the bridge where you can put the thing and make a lot of problems for, Legolas and Gimli and everybody in Helm's Deep, right? So if we know that that's there, then why don't we identify it and then drive contributions towards solving this problem and recognizing it? So there will always be a sort of snakes and ladders type dynamic with cops and robbers or bad guys and good guys or whatever you want to call it, right? There
Okay.
will always be an adversary and a defender. And the cycle that you go through to meet each other is actually more important than whether or not you get into the cycle at all. You're going to be in the cycle. So your ability to quickly cycle through the attackers' capabilities and solve them and work together and align your community to do it is more likely to solve the problem than pretending that it's not there or hoping that nobody finds out. And it's kind of a bummer because it means you're going to be like Sisyphus, like constantly pushing a boulder up and down a hill. But that's why this grand unified theory of conservation of effort is so important. Because if people understood that we already have a sprawling, vast network of software dependencies that is not really maintainable, then why should we be adding more attack surface to that? Shouldn't we be focusing on the dependencies that everyone needs to work on to have a common ground, the stack, so that it's aligned so that we can secure that thing, right? Um, there's another one. It's the bigger your horde, the more likely you're going to see dragons, right? So when you create these like concentrated centrality networks of value, that actually creates a path of least resistance to getting the most utility by doing nefarious things, right? So by structuring your communities in federated ways or under zero trust, or there are a lot of different analogies or devices in open source that like PGP or, you know, I, without going into all of them here, there are ways that you can attempt to navigate uncertainty and ambiguity while aligning things. But uh, to be in tech is to always have work to do. To be in open source means to admit that software is never done and the work is never done. So uh, hopefully by working together and aligning with your community, you're going to be more likely to address the stuff that people need and plug those holes before they get found.